Hi everyone, my name is Thomas and I'm very pleased to introduce QUAREP LiMi Working Group 10, Image Quality. In this very short presentation, I will try to describe the purpose and the challenges of this working group that I have the pleasure to co-lead with Ulrike Böhm and Bruno Sanguinetti. This project and the issues underlying it are very ambitious. Of course, we do not pretend to define image quality in microscopy in an absolute way. Many people are working on this subject full time, and we are just a bunch of volunteers trying to help the community to see more clearly in the image acquisition chain in order to optimize the image settings. The aim of this working group is to try to establish an image quality score according to precise parameters, which I will describe to you, and which have, as a primary goal, to find common definitions for the entire microscopy community. Hence the subtitle, what defines image quality? A microscopy community's point of view. At present, our working group has 141 members, of which more or less 20 are active at our monthly meetings. Of course, image quality can have as much definition as number of microscope users. Here we will try to focus on the one that state that a good image quality in the field of light science is an image acquired with a minimum number of photons capable of answering a specific biological question. And this is how we proceed. At the center is the biological question that microscopy can answer using the appropriate technique. The health of the microscope should first be assessed, preferably using the protocol established by QUAREP working groups 1 to 6, or by looking at the work of Faclaris and colleagues. Each of the measurements, such as the PSF or co-registration, can lead to a confidence index on the acquired image. Secondly, we need to look at the metadata from the microscope, because an image without any metadata is a useless image. For this, we are working in collaboration with the Working Group 7 metadata of QUAREP LiMi. Then, following image acquisition, several parameters are calculated to describe the quality of each individual images. These three scores, image quality control, metadata, and quality score, establish an overall image quality score that can be used to help adjusting acquisition settings or as an input parameter for image processing, for example. The global vision we have is to consider establishing a matrix that would have as input the most common biological problems and associated microscopy techniques that would guide users to the optimal microscope settings. Of course, we are not yet here. We are still working on the definitions of the different quality score parameters, which I can present here very quickly. First, we have the rawness of image data. This parameter aims to estimate if an image has been modified from the raw original values at the input of the sensor. Signal to background ratio is very hard to calculate without human intervention, but we are still working on it. And we have the signal to noise ratio, which can be estimated if we have the right metadata. Then image dynamic range, contrast, and the square root of the maximum photon detected are values of interest about the properties of an image. Lateral and axial sampling rate are values deductible from the image calibration and are of importance to determine if Shannon-Nyquist criteria has been met, for example. And then image resolution estimation will allow us to automatically assess the level of details we can expect from an image. Finally, this diagram gives an overview of how we calculate our different parameters from a single image. We plan to write a global code in Java and Python integrating all these different parameters. As you can imagine, each parameter has to be precisely and very precisely defined, which gives rise to a lot of very nice discussions in the group. This work is progressing slowly but surely, and we will soon be able to calculate some of these parameters automatically. So thank you for your attention, and then we are happy to answer to your question if you have some.